So let's try to solve this problem using Python. The idea here is to see what is the impact of very small cheating, very small bias that is introduced in the coin on the outcome of the game. Does it impact very drastically, or is it a very minor impact? So as per the definition of the problem, we have a coin which is biased. The probability of head is 0.49. The probability of tail is 0.51. Very small bias in the coin. And John starts with $10 and his initial game counter is 0. And we are going to play this game until he runs out of money. And every time he plays this game, his game counter increases by 1 and he has to pay $1. So $1 gets deducted from his money. And at the start of every game, he has the choice to choose between head or tail. That's what this line of code does. And after that, the coin is tossed and a head or a tail is encountered. However, the probability of head is 0.49 as given here, and probability of tail is 0.51. So this line of code introduces bias in the outcomes. And then we take this result and try to match it with John's choice. If result is same as what John had chosen, then he's a winner. He gets $2. Otherwise, the game continues, and next time he plays this game, $1 is deducted from his overall money. So this is what is the entire problem definition. And now we simulate 50 such games, and we keep track of how many number of games it has taken before John ran out of money. So we store that count in this variable, and we run this simulation 50 times, and we try to see what is the minimum number of games that it takes for John to become bankrupt. So here is the first simulation, and this is the list. This list depicts the number of games it has taken before John ran out of money. So this is the condition that we are just testing, and as you can see that contrary to the popular belief that one needs to cheat very heavily to outsmart somebody, it takes very small amount of cheating to make somebody go bankrupt. It just took 20 games before John became bankrupt. So these are total 50 simulations, and the highest number is 67,264. So we can continue to play this game or run this simulation as long as we want to, and you see that it is very surprising that just about 16 games is sufficient to make John go bankrupt. Now, why is this thing very important? Because most of the games of chance, be it in casinos, be it card games, be it stock market, be it fantasy sport, you will not find very big difference or rigging in the game. Casino rigs the game only by 1%, and every time you play the game, no matter how many number of times you play the game, in all these 50 attempts, every time John is a loser. Sometimes he loses just in 16 games, and sometimes it takes him 87,000 games to lose. But eventually he will go bankrupt playing this game. So that's how all game of chance in real world are rigged against the investor, against the trader, against the people who are playing these kind of games, and you will never be able to figure out the difference in cheating, because you just need to introduce only 1% bias in the outcome, and that's how the casino always wins.